Hello everyone, welcome to this new tutorial on NumPy reshape function. So without any further delay, let's get started. First of all, we'll import the package NumPy, import NumPy as NP. And as we all know, NumPy is generally used for array manipulation. So we will start with an array. We'll create an array which has 10 values, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. These 10 values has to be enclosed within a list. We will print the value of array A and we will also print the type of array A. Formatting purpose, let's use F type string formatting. Yeah. So we see the array has 10 values and the type of array is numpy.ndarray. And also if you want to see the shape of array, so for that we can say shape of array, array A is, we can use this function a.shape. So the shape of array A is 10. So it is a one dimensional array with the first dimension having 10 values. So that's what it says 10 comma. Now in the next step, we'll see how to create a array which is a 2D array. So for a 2D array, again we'll create a 2D array np.array with 2 rows and 3 columns. So the 3 column values of the first row will be 1, 2, and 3, and the 3 column values of the second row will be say like 4, 5, and 6. And this has to be saved in a list. If we copy these 3 statements over here to save time, so we can see a 2 by 3 array. We can think of it as a matrix which 2 rows and 3 columns. And the type of array is numpy.ndarray and the shape of array is 2 by 3. So it has 2 dimensional, where the first dimension is 2 and the second dimension is 3. So in the next step, what we'll do is we will create a 2 by 3 matrix A and a 3 by 4 matrix B, and we'll multiply those two, which is basically a dot product. And as we know, when we multiply a 2 by 3 matrix with a 3 by 4 matrix, the resulting matrix is a 2 by 4 matrix. So that's the value C. So let's get started on how we can do this. So for that, we'll create two arrays. One array A, which will be having value 2 by 3. So basically, we will start with a plain array which has like 6 values in it. So because 2 into 3 is like 6, total of 6 values are present in array A. So for that we use np.arrange, and np.arrange will return 6 values starting from 0 to 5. Similarly, we will be creating an array B which will be having 3 by 4 values. So basically 4 into 3 is 12. So we will be having 12 values in array B. So we have our B array. Next, we will look into the shape of array A and shape of array B. Shape of array A is 6 and shape of array B is 12. So it's a single vector with 6 values in it, and it's a one dimensional vector with 12 values in it. Now comes the reshaping power, using which we will be creating this matrix multiplication. So you see, so we have array A which has 2 by 3 and array B which has 3 by 4, and our resultant array will be 2 by 4. So let's see how we can convert this particular array A into a 2 by 3 array. So now we will be creating a new array A underscore reshape, and we'll be reshaping the original array A into a 2 by 3 matrix. If we see the reshaped version of the array A, so the array A, which was earlier a single dimensional array with 6 value in it, has been reshaped into a 2 by 3 array, where the initial 3 elements are the first row and the last 3 elements are the second row, and the shape of A reshaped is 2 by 3. Similarly, we'll do similar kind of exercise for the array B. So the array B, which earlier had 12 values in it and a single dimensional array, now using this particular reshape function, and we pass the values of the first dimension and the second dimension. The first dimension is of length 3 and the second dimension is of the length 4. That's how like 3 into 4 are like 12. So if we run this cell, so we can see the array B, which was earlier having 12 values in it, has been transformed into a matrix of 3 rows and 4 columns, or a 3 by 4 matrix, and the values have been adjusted accordingly. Now I would like to share with you a hack, or the -1 trick, which is widely used in NumPy array manipulation. Say you want to convert this B underscore reshaped matrix from a 3 by 4 matrix into a single dimensional array. So you can directly put B reshaped dot reshape -1. So basically what it does is like it converts whatever the array shape into a single dimensional array. Or in other words, this is like 3 by 4 matrix, but you want to convert it into a 2 by 6 matrix. You know the number of records that you want to give, but you are not sure about the number of columns. So you fix the number of rows as 2 and you let NumPy do the rest of the calculation, and you can see it has been converted into an array of 2 by 6. If you see over here, we have like 2 rows and 6 columns. So it's a matrix of 2 by 6. So that's the power of NumPy -1 trick. What it basically does is like given the first dimension of the array, it will automatically infer the next dimension of the array. And finally, I would like to complete the whole of the tutorial by calculating this resultant vector, or like the resultant matrix, which is the matrix multiplication of A and B. So our A matrix is of shape 2 by 3 and B matrix is of shape 3 by 4. So when we multiply these two, we should be getting 2 by 4. But remember, it should be a dot product multiplication, which is a special kind of multiplication. So if we do something like A reshaped multiplied by B reshaped, this will throw an error, and it says like it can't multiply A reshaped by B reshaped because of some dimensional issues. So the operator that helps in dot product is basically at the rate. So when you write it at the rate, it will do a dot product of it. And finally, we'll be getting our matrix C. So as you can see, when we multiply 2 by 3 matrix with the 3 by 4 matrix, the resultant matrix is a 2 by 4 matrix. So we can see like over here, the 2 by 4 matrix looks like this, and these are the final values of it. So where can we see this reshape function in action in a real world project? For that, click on the icard that is being shown on the top. That will redirect you to a project based course where we can see how that reshape function is being used to reshape the matrix and create a real world project. Thank you.